In 2002, the HSE commissioned the Ergonomics Department of Loughborough University to carry out research into ladder stability. This 250-page document became known as the 2004 Loughborough Report, and it identifies four main modes of ladder failure: bottom slip, loss of top contact, flip, and sideways slip. In this video we will demonstrate how to prevent the two most common causes, bottom slip and flip. Bottom slip occurs when the ladder loses frictional contact with the supporting surface. Ladders rely totally on friction at both the top and bottom to keep them in position. To demonstrate how critical this is, we carried out workshop tests with the ladder standing on PTFE and leaning against a stainless steel sheet. The low frictional qualities of the two surfaces allowed us to witness ladder movement by using small, manageable weights. This is a 2015 EN131 ladder leaning at 70 degrees with a weight of just 4 kilograms suspended from the second top rung. It slipped immediately. This is the same ladder fitted with a prototype stabilizer bar to comply with the new EN131 2017 ladder standard, again with the suspended 4 kilogram weight. There was no significant improvement. It moved 40 millimeters in less than 1 minute. Next we added a prototype road jack stabilizer. We started with the 4 kilograms and then added a further kilogram per minute until the load reached 10 kilograms, at which point movement was detected. It then took 4 minutes to move just 40 millimeters. We then moved the PTFE base away from the wall to decrease the ladder angle to 60 degrees and dispensed with the weights. Upon release, both the naked ladder and the ladder with the wide bar slipped immediately. In contrast, the ladder with the integrated road jack stabilizer doesn't move at all. How does it work? Remember, ladders slip when weight on the ladder overcomes the friction holding it in place. However, this prototype road jack stabilizer absorbs the forces that cause movement, thus converting a negative into a positive. In the year 2000, when work first started on the EU mandate to improve the EN131 ladder standard, there was a misconception that sideways slip was a major cause of ladder accidents. It isn't. The HSE filmed the following demonstration at their HSL laboratories in Buxton. The 60 kilograms weight was attached to the bottom rung of a ladder and a technician instructed to attempt to make the ladder collapse by leaning out. But he found it impossible to make the ladder fall sideways. The 60 kilogram weight was then replaced by another technician footing and bracing the ladder. Look closely and you'll see not only is the man wrestling with the ladder, but the ladder's wrestling back. We have now taken away both the 60 kilogram weight and the man at the bottom, and this is what happened. The ladder immediately flipped. These two safety interventions hadn't been preventing sideways slip, they'd been preventing flip. Flip is when the user leans out to one side whilst hanging onto the other stile and the ladder rotates. Here we changed the base test surface to a plastic laminated one, which is slightly more frictional, as neither the naked ladder or the one fitted with the stabilizer bar would stay upright on PTFE with a 10 kilogram weight attached. We now loaded 10 kilograms as a token weight onto the ladder, whilst attaching an industrial rope to the middle of the left-hand stile. This rope was passed away from the ladder horizontally at 45 degrees and over a pulley. We then added weights vertically to exert a sideways force to the stile, mimicking someone leaning out to the right, causing the ladder to flip. These tests are all comparative as they deal with each product in turn on the same surface at the same angle. Only the added weights vary depending on the performance. Upon applying 10 kilograms, the naked ladder flipped. The wide bar began to flip at 7 kilograms before totally failing at 10 kilograms, suggesting that it isn't necessary to widen the ladder base, as the extra width has no effect on preventing flip. The Rojack prototype, meanwhile, is only marginally wider than the naked ladder, yet it increases the ladder's grip and resistance to flip. We then moved the base away from the wall to decrease the ladder angle to 65 degrees and repeated the tests. Moving the base of the ladder away from the wall increases the grip at the top of the ladder, providing the grip at the base of the ladder will support it. Upon applying a 10 kilogram weight, the naked ladder flipped again. But the wide bar failed to reach half that amount before failing, whereas the Rojack prototype comfortably exceeded 10 kilograms. Finally, this is a Rojack multi-stopper, which has been certificated by BSI that it fully passes the Loughborough stability test. Although this ladder system only has a weight of 10 kilograms on it, it resists a 23 kilogram weight trying to flip it.